Good afternoon, everyone. Excuse me, sorry. Welcome back to NSR Programmer. We're continuing with learning Solidity in Ethereum via Remix. And today we're going to be covering Structs, or what we call structures. So just to give a brief introduction to what a struct is, the definition of a struct, which is again short for structure. A struct is a custom data type that you define to group together multiple related variables under one umbrella. Excuse me. Yeah, sorry. So unlike primitive variables, like for them they hold a single value like a number or a boolean. A struct bundles different data types into a single object. This helps organize and manage complex sets of data logically and improves code readability and maintainability. A real-world analogy, like for an example, like you could think of a struct like a form or a record that contains fields such as name, age, and address, all bundled together rather than separate variables scattered around. I could give you like maybe 4 reasons why we use structs in Solidity. Excuse me. Reason number 1, to logically group related variables. For example, you'd say like user details like their name, their age, and their wallet address. So you can logically group those related variables because they are user details. Reason number 2, to reduce clutter and duplication by managing related pieces of data as one unit. Reason number 3, to define complex data models which are easy to expand and maintain. Reason number 4, to make your contract code cleaner and easier to understand. Quickly, let me show you how to declare a struct in Solidity. I'll use one of these that I had made earlier. So you have a struct and we give it a name, and let's say type 1, variable 1, type 2, variable 2, type 3, variable 3. So this is how a struct can be declared in Solidity, right here. So you use the keyword struct. Yeah, this is the keyword struct, and then you use the keyword struct to declare a new data type. Excuse me. Named struct name. That's the name of the struct. Inside the curly braces, we define the fields or members of the struct with data types and variable names. So fields can be of different types. Could be an unsigned integer, it could be a string, it could be a boolean, it could be an address, it could be an array, or even other structs. Structs can be inside and outside contracts. So a struct can be declared inside a contract, so that will make it local to that contract, but it can also be declared outside any contract in a separate file and imported wherever needed, promoting basically code reusability. So let's look at a quick demo of an example of a struct and a contract. Let's get rid of this. Create a new file. So I'm going to just quickly, or as quickly as possible, write the code, and then we'll break it down after I finish. Yeah, declare. So this is a struct inside the contract. excuse me. I'm just doing some final checks. Yeah, so now let's start to, let me try and break down what's happening. So of course the first line, declaring the open source license, and specify the Solidity compiler to use. So we have a contract from line 4. We've declared a new contract named to-dos, which acts like a class containing containing all our code, and then we declare a struct called to do. So it has two fields. The struct has two fields. A text, which is a string to hold the to-do item description, and boolean, rather, completed, which is a boolean, true or false, indicating if the to-do is done. Then line 12, that's we're declaring a dynamic array named to-dos, holding multiple to-do struct items. It's declared publicly, so Solidity generates an automatic getter function to access to-dos by index. Line 15, that's a function to create and to create or add a new to-do. So it takes a text input and then creates a new to-do with text is equal to underscore text and defaults completed to false. So text and then false. The string being underscore text and then the boolean being false. The to-do is then pushed onto the to-dos array, and then from function get unsigned integer 256, that's line 20 here. Line 20. That function is basically to read the to-do's details by array index. So it returns the text and the completion status of the to-do, uses storage pointer to reference the to-do in contract storage. And then we have the next function to update the text of a to-do. That's from line 25. Sorry. that function is, we're using it to update the text of an existing to-do at a given index. So it accesses the to-do in storage and then modifies its text field. And then the last function from 31, basically 32, that function is to toggle the completion flag. So it changes completed from true to false or from false to true by using the logical not operator. And then of course the contract ends there. Yeah, so that's basically how I could try and break down what this is doing. Yeah, can compile. Deploy. Yeah, so let's try and interact with it. You can just put in few values. one more. So when we call the to-dos, the expected outcome was this, but it's not completed. So, yeah. So these are the indexes. 0 being the first that I created, which was to prepare or rather buy groceries, and then number 1 being prepare a report, but they're both not completed. Yeah. Let's see. Let's just change the status of the first to do. And then if we call it here, it should bring completed, which means true. Yep. Yeah, so that's it. Excuse me. Let's basically how to create structs within a contract and then interact with them. Otherwise, thank you for joining us today. Please don't forget to like and subscribe to the channel, share the video. Yeah, thank you.